Hello and welcome to AWS Innovate. My name is Harpreet Singh and I'm here with my friend and colleague Santosh Chaudhary. We are both SAP Solution Architect at Amazon Web Services. In this session on SAP on AWS, big businesses, big workload, big time, I'll talk about how SAP on AWS is different and how customers are getting benefited from those differences. Then Santosh will discuss about data lake in general and specifics of SAP data lake on AWS. He has worked with our partner Bright System to prepare a use case that customers sentiment analysis using sales data from SAP and sentiments from Twitter feeds. He will walk you through the architecture as well as a live demonstration on how this solution works. While working on field with different customers and partners, we are consistently hearing positive experiences our customers are having while running their SAP applications on AWS. They tell us that SAP on AWS is different. Let's look at some of those differences that they have shared with us. SAP historically is a complex, long-running, required detailed planning and involved different teams with different technical and business skills. Due to all these complexities, SAP projects, at least in my experience, never finish on originally planned budget and time. One of the major reasons for this is availability of infrastructure on time when needed. Our customers are telling us that they are delivering SAP projects on AWS at much faster pace and within time and budget. Agility is another differentiator. AWS, its set of services enables our customers to implement SAP solutions quickly. For example, SAP HANA Quick Start, which is CloudFormation template, gives capability to deploy SAP HANA on AWS in under 40 minutes. Our services like AWS System Manager, Amazon CloudWatch, AWS Step Functions, etc. help to simplify SAP operations as well. Due to all these automation capabilities, our customer Del Monte, working with our partner Accenture, has been able to migrate their SAP landscape in 3.5 months, which was originally planned for 7 months. Customers are telling us that their applications on AWS cloud is much more secure than they are in their own data center or private data centers or co-locations. AWS provides services with which customers have full control on access, audit, monitoring, and capabilities to encrypt data at rest as well as in transit and more. With our shared responsibility model, customers can focus on ensuring security in the cloud while having peace of mind that AWS is working 24/7 to ensure security of the cloud. Flexibility is another major differentiator, as customers can start small and grow as they need to. This helps reduce costs significantly. Our customer, Contact Energy, has been able to reduce their cost to half compared to private cloud and has been able to get return on investment in less than 12 months. Talking about flexibility, AWS provides wide list of instances to deploy SAP workloads. There are over 30 instances certified for SAP applications and relational databases supported by SAP. Customers on AWS can start small and move to larger instances whenever required. In terms of SAP HANA, AWS is certified from 244 GIB to approximately 4 terabyte in scale-up configuration, while up to 50 terabyte for SAP HANA scale-out scenario. Our X1 and X1E family of instances are specifically engineered for in-memory workloads like SAP HANA. AWS offers its largest X1E 32x large instance, which provide approximately 4 terabyte of memory with same flexibility as its smallest instance in T2 family. We know our customer need much larger than 4 terabyte instance that we offer today. And with our principle of working backward from customer's requirement, we have announced our roadmap to engineer SAP HANA instances of size 8 and 16 terabyte. We are working to deliver these instances within this year. Well, that was a brief introduction about SAP differentiators on AWS. I'll now hand over to Santosh to discuss about SAP Data Lake on AWS.
Thank you, Harpreet. Hi, everyone. My name is Santosh Chaudhary. In next few slides, I'll walk you through what is a data lake, why it's important for an SAP customer, what are the keys of some characteristics to keep in mind while designing a data lake, and then we'll see a demo on customer sentiment analysis using insights from SAP sales, billing, shipping data, and Twitter feeds outside of SAP. The size and complexity of data that needs to be analyzed today means the same technology and approaches that worked in the past don't work anymore. First, data is growing exponentially with machine-generated data from internet-connected devices growing 10x faster than data from business applications. This makes it impractical for customers to purchase and install larger and more powerful hardware each time storage and compute capacity limits are reached. To move massive amount of data to a separate analytic system prior to analyzing it. Second, the types of data are changing from traditional operational data that are structured as tables and columns to data being generated by new sources like social media, mobile apps, websites, devices. Customers can no longer constrain their analytics to relational data, but need to store and analyze any type of data, including non-relational data without refined relationship or schema. Third, as data is generated in real time, customers need to go beyond analyzing historical data to analyzing data in real time. So what is a data lake? Data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. You can store your data as is without having to first structure the data and run different types of analytics from dashboards and visualization to big data processing, real-time analytics, machine learning to guide better decisions. AWS provides the most comprehensive, secure, and scalable, cost-effective portfolio of services that enable customers to build their data lake in the cloud and analyze all their data with the broadest set of analytical approaches, including machine learning. As a result, there are more organizations running their data lakes and analytics on AWS than anywhere else, with the customers like Netflix, Zillow, NASDAQ, Yelp, iRobot, and FINRA trusting AWS to run their analytics workload. A data lake is a new and increasingly popular way to store and analyze data because it allows companies to manage multiple data types from a variety of sources and store this data, structured and unstructured, in a centralized repository. It then provides appropriate tools and access mechanism to various business roles and personas to gain crucial insights from this data. Let's see why a data lake is relevant for SAP customers. SAP has become a synonym for industry standard ERPs at many big organizations. It stores data corresponding to various business functions like marketing, sales, delivery, invoicing, in addition to purchase order and supplier relationship management, to name a few. Leveraging data lake capabilities of analyzing this data with that coming from non-SAP sources opens a world of new possibilities and opportunities for data scientists, business analysts to gain deep understanding of their organizational productivity, growth, customer needs, and competitive awareness. However, due to various challenges in past, it has been difficult to consume enterprise data with non-SAP data coming from other sources. But with AWS Cloud, customers can leverage the platform for processing both SAP and non-SAP data together. Let's look at the typical characteristics of a data lake and how are they different from a traditional data warehouse. Traditionally, analytics was run through a relational data warehouse. It collects data from multiple sources and produces operational report. This method of analytics had few characteristics. It was optimized for relational data sources. It scaled up to petabyte scale. It required the question to be answered prior to data warehouse design because schema had to be created to know what type of data is loaded into the data warehouse. It enabled operational reporting on top of data warehouse and thus resulting in higher CapEx and OpEx cost. The belief that data is an asset is causing pressure on traditional architectures. It can't be business as usual anymore because these new customer requirements might break the traditional approach. Customers need to capture and store new non-relational data at exabyte scale. Customers want to store new non-relational data that is being sourced from different places not currently in data warehouse. This includes machine-generated data, log file, clickstream, social media, etc. These new sources of data are being generated at a high volume that can scale to exabyte size. The traditional data warehouse is not optimized for storing these non-relational data because it was designed for relational data at petabyte scale. Customers want to have a single view of all their data, and they want an easy way to catalog, search all these data to do analytics on top of it. Furthermore, they want their data to be secured to prevent unauthorized access. The traditional data architectures were not built to account for this. Data exists in silos, or if they are centralized into an enterprise data warehouse, it is extremely costly to build ETL on top of it. They want to move from answering questions that happened in the past to using statistical models and forecast techniques to understand and answer what could happen. To do this, customers need to move to incorporating machine learning, big data processing, real-time analytics. However, their traditional architecture could only accommodate reporting and ad hoc analysis on relational data. To get the most value from their data, customers need a scalable, secure, and comprehensive data storage and analytics platform. Customers need to be able to securely store data coming from applications and devices in their native format with high availability, durability, at low cost, and at any scale. That is, they need a data lake. Customers need to easily access and analyze data in a variety of ways using tools, frameworks of their own choice in a high-performance, cost-effective way, without having to move large amount of data between their storage systems and analytics system. And customers need to go beyond insight from operational reporting on historical data to being able to perform machine learning, real-time analytics to accurately predict future outcomes. So what happened? Are EDW now dead? Not really. Data lakes are complementary to EDW and not a replacement. Let's take a look at some of the key differences. A data warehouse is a database optimized to analyze relational data coming from transactional systems and line of business applications. The data structure and schema are defined in advance to optimize for fast SQL queries, where the results are typically used for operational reporting and analysis. Data is cleaned, enriched, and transformed so it can act as a single source of truth that users can trust. This is a functional architecture of a data lake. To build your data lakes and analytics solution, the AWS cloud provides many of the building blocks required to help customers implement a secure, flexible, cost-effective data lake. These include AWS managed services that help ingest, store, find, process, and analyze both structured and unstructured data. Importing your data from on-premise in near real time, storing any type of data securely from gigabytes to exabytes. Amazon S3 is a secure, highly scalable, durable object storage with millisecond latency for data access. Amazon Glacier is a secure, durable, and extremely low-cost storage for long-term backup and archive that can access data in minutes. AWS provides the broadest and most cost-effective set of analytics services that run on the data lake. Each analytics service is purpose-built for a wide range of analytic use cases, such as interactive analysis, big data processing using Hadoop and Spark, data warehouse, real-time analytics, operational analytics, dashboards, and visualization. Use machine learning to forecast future outcomes and prescribe actions. AWS Glue is a fully managed service that provides a data catalog to make data in the data lake discoverable and has the ability to extract, transform, and load to prepare data for analysis. For interactive analysis, Amazon Athena makes it easy to analyze data directly in S3 and Glacier using standard SQL queries. For data warehouse, Amazon Redshift provides ability to run complex analytic queries against petabytes of structured data and includes Redshift Spectrum that runs SQL queries directly against exabytes of structured or unstructured data in S3 without the need for unnecessary movement of data. For real-time analytics, Amazon Kinesis makes it easy to collect, process, analyze streaming data such as IoT telemetry data, application logs, website click streams, and so on and so forth. For operational analytics, such as application monitoring and log analytics and clickstream analytics, Amazon Elasticsearch allows you to search, explore, filter, aggregate, and visualize your data in near real time. For dashboards and visualization, Amazon QuickSight provides a fast, cloud-powered business analytics service that makes it easy to build stunning visualizations and rich dashboard that can be accessed from any browser or mobile devices. In the demo, I'll be using tools from our big data partner, Bright. Bright uses its ingestion tool, which can be used to bring near real-time updates and data from databases onto S3. In this example, Bright data ingestion tool is used to extract data from SAP running on SQL Server. In addition to it, Data Blend, which is another tool from Bright, can be used to transform and model the data for analysis and machine learning and storing it in another data source like Amazon Redshift. For this demo, I have focused on following tables: VBAC, SAP Sales Document Header; VBAP, Sales Document Item Data; VBRK, SAP Billing Document Header; VBRP, Billing Document Item Data; and LIBS, which is Sales Delivery Item Data table. Using Bright ingestion, this is brought onto S3, which can then be queried using Athena. This data, depending upon further analysis, can also be copied to Amazon Redshift for structured analysis or can be used for ad hoc analysis using Amazon Athena. Amazon Athena is an interactive query service that makes it easy to analyze data in Amazon S3 using standard SQL. With Athena, there is no need for complex ETL jobs to prepare your data for analysis. This makes it easy for anyone with SQL skills to quickly analyze large-scale datasets. In this demo architecture, live Twitter feeds filtered on text phrase selection is streamed into S3 bucket using Amazon Kinesis Firehose. When a new Twitter feed is stored in S3 bucket, it triggers a Lambda function to analyze the tweets using Amazon Translate and Amazon Comprehend to fully manage services from AWS. Amazon Comprehend is a natural language processing service that uses machine learning to find insights and relationship in text. It can identify the language of the text, extract key phrases, places, people, brands, or events, understand how positive or negative the text is, and automatically organize a collection of text files by topic. Amazon Translate is a neural machine translation service that delivers fast, high-quality, affordable language translation. A separate Kinesis data delivery stream within Amazon Kinesis Data Warehouse is used to write analyzed data back to S3 in a separate bucket. Analyzed data from Amazon Comprehend is ready to be queried from Athena or AWS Glue Crawler and can be used to create a catalog of the table for use with Athena for interactive reporting. Finally, QuickSight shows dashboards showing the customer positive or negative feedbacks. It also shows dashboard of overall sentiments. Let's take a look at the demo. In part 1 of this demo, a fictional manufacturing company is using SAP ERP to create, process their sales, billing, and delivery of their product. We'll see how to consume data from SAP tables for typical sales and delivery analysis using AWS services. We are using Bright ingestion tool here to extract data from SAP. Data is captured near real time through CDC, and it can be further transformed using Bright modeling tools. In this demo, we have created a custom view of tables like sales document header, document item, billing header, billing document item, and sales delivery item data tables. This is a sample data extraction from S3 using Amazon Athena. All right, let's log into SAP MMC. So this is SAP MMC console. Here SAP is running on SQL Server. There is a custom table created joining SAP tables mentioned earlier, and it contains around 14,000 records. When data is extracted using Bright ingestion tool, these are the buckets created on S3, data underscore SAP and delta underscore SAP. Each table has its own bucket, and data is stored under data underscore SAP, and delta changes are brought through CDC are captured in delta underscore SAP buckets. There is also a manifest file which contains the metadata for the table structure. This is our custom table created in S3, which is brought onto from SAP using Bright tool. Once the data is available in S3, it can be queried using Amazon Athena using standard SQL. Here is a tabular report of sales data, which contains details like sales document, creation date, customer number, sales date, shipping condition, and so on and so forth. So here you can do the entire data analysis. In part 2 of the demo, we'll be using manufacturing companies' social media records to analyze how product reviews and sentiments are coming from consumers. Data from Twitter feeds are extracted using Amazon Kinesis stream into raw folder. Lambda triggers the Kinesis firehose to store analyzed data in separate bucket, and which is further accessed using Athena and QuickSight. All right, switching to console. There are 3 Kinesis streams responsible for streaming tweets and storing analyzed data and entities in the bucket. Let's look at the raw bucket. Twitter feeds matching the phrases are captured in this bucket. And these phrases could be the product specific, which this manufacturing company is trying to capture from tweets. This is the Lambda, which is triggered when a new feed arrives. Here is a Lambda function, which calls Amazon Comprehend and Amazon Translate to analyze the tweets and categorize it as positive or negative sentiments. Data is stored into S3 under sentiment bucket after it's processed and categorized by Comprehend. Let's look at how data is saved in sentiment folder or sentiment bucket. And once this data is available in S3, it can be queried using Amazon Athena. So I'm just doing count star on total number of tweets and count star on how many tweets have sentiments attached or discovered by Amazon Comprehend. Let's look at the QuickSight console. As you can see, there are 4 dashboards. First dashboard is overall sentiment on that product. As you can see here, 83% positive reviews for the product. So in this case, manufacturing company is happy because customers are giving good feedback. Second and third dashboard shows comparison of various sentiments and changes in sentiments over the period of time. It could be because of new bugs or issue which is discussed among the users. The fourth dashboard gives various sentiments scattered across geos and gives a good insight on the user perspectives for the product across the geos. All right, to conclude this demo, we were able to analyze both structured data coming from SAP and non-SAP from social media and process using AWS services. To summarize, a data lake can be used as a source for both structured and unstructured data, which can be easily converted into a well-defined schema for ingestion into a data warehouse or analyze ad hoc to quickly explore unknown data sets and discover new insights. Some of the best practices to keep in mind: configure your data lake to be flexible and scalable so that you can collect and store all types of data as your company grows, including design components that support data encryption, search, analysis, and querying. Implement granular access control policies and data security mechanism to protect all data stored in data lake. Provide a mechanism that enables users to quickly and easily search and retrieve relevant data and perform new types of data analysis. Leverage managed services for multiple methods of data ingestion, and for example, use Amazon Kinesis, Amazon Snowball, AWS Direct Connect to transfer large amount of data. Then use powerful services such as Amazon EMR, Data Pipeline, Amazon Elasticsearch to process the data for meaningful analysis. The native features of S3 are exactly what you want for a data lake. Replication across AZ for high availability and durability, massively parallel and scalable, storage scales independent of compute, low storage cost at less than 2.5 cents per gig. This is nearly impossible to achieve with a fixed database cluster. The ability to harness more data from more sources in less time and empowering users to collaborate and analyze data in different ways leads to better, faster decision making. We have come to the conclusion of the session. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all business benefits that AWS has to offer. To learn more about APN partners and find the right one that fits your need, please visit the AWS APN booth at our showcase. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. Attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS, and validate your technical expertise with AWS and use practice exam to help you prepare for AWS certifications. Finally, I would like to thank you for attending today's session and sticking it out until the very end of the presentation. Enjoy the rest of the sessions. Thank you.